if two waves are moving in opposite direction, all right, so relation between phase difference and path difference. So this is the simple formula for relation between phase difference and path difference. Phi is equal to 2 pi by lambda into delta x, where del phi, this one is the phase difference, and this one will be the path difference. So this is the relation between phase difference and path difference. Now we know for maxima, if two wave interfere, for maxima their phase difference should be equal to 2n pi, and for minima their phase difference should be equal to 2n plus 1 pi. Similarly, if I put this one in this formula over here, so delta phi is equal to 2 pi by lambda into delta x. Delta phi I can write 2n pi, so 2n pi is equal to 2 pi by lambda into del x. Now pi and pi get cancelled, finally del x will get n into lambda. It means for minima, what is the, it means for maxima, what is the phase difference? This one. And for maxima, what is the path difference? This. Similarly, for minima, phase difference is this one. And if I substitute this equation over here once again, so what I'll get, 2n plus 1 pi is equal to 2 pi by lambda into del x. And if I solve this one, del x, I'll get n plus half into lambda. So in conclusion, phi is equal to 2n pi. This is phase difference for what? Maxima. And delta x is equal to n lambda. This is the path difference again for maxima. And if I write phi is equal to 2n plus 1 pi, this is the phase difference for minima, and delta x path difference for minima, that is n plus 1 by 2 into lambda. So this formula we are going to use directly in the numericals. So let's solve one numerical based on that one. This is the one numerical, and in this numerical what they are asking, yes, in this numerical what they are asking, yes, source emitting a light, or source emitting a light of frequency 180 hertz is placed in front of a wall of distance 2 meter, means this distance is 2 meter, and a detector is also placed in front of wall in same distance, some distance from the it. So this is the detector and this one is the source, and this is the distance between wall and the source, that is 2 meter. Find the minimum distance between source and the detector for which detector it is detect the maximum of the sound, means maxima should occur, and speed of sound is given 360, sorry, speed of sound is given 360. So basically they are asking, this is the source, this one is the source, this one is the detector, and distance, this distance is 2 meter. They are asking here, air should be maximum sound, it means maxima should occur. So what is this distance? This distance they are asking for, so that detector receive maxima. So what I'll do, just I will find out path difference. We know path difference for maxima delta x is equal to n into lambda, and we are asking for first maximum, first time when we hear the maxima. So what I can write here, delta x is equal to lambda. In place of n, I am writing 1. So delta x is equal to lambda. And if I calculate this lambda, lambda is equal to v divided by f. V is given 360 and f is given 180. And if I solve this one, that will be 2 meter. Lambda again 2 meter. Now, if you see the path difference of this one, difference in the path means this path, this blue line, basically this white line, and this red line. So if I see the first part of red line, S to O, this one, first part of red line, this one, S to O, so that will be equal to, if I make that diagram over here, so this one is 2 and this one will be x by 2. If I calculate this one, that will be 2 ka square plus x by 2 ka square. but this distance is twice, means this distance is here and this distance also here, means after striking, if it cover and reach at point D, it has to cover S to O, then O to D, and directly if it is going, it has to cover only a distance S to D, that is X. So if I find out path difference, in that case, what should be path difference of this one? Delta X, that is equal to 2 times of X square by 4 plus 4. Means whatever distance, means that SO distance I take 2 times, because SO also I have to count, and then OD also I need to count. So it's going like this one, from S to O, then O to D. One path, second path is only S to D. I just calculate this distance, that is 2 square, that is 4 plus x square by 4 under root this value, but I make it twice because that distance S2 then O2D. Now if I subtract this x from this one, so I will get path difference, and that path difference should be equal to lambda. If I solve this complete thing, so what I'll get, x square by 4 plus 4 is equal to 1 plus x by 2, and this one is under root. If I square both sides, so I'll get 4 plus x square by 4 is equal to 1 plus x square by 4 plus x. Now this x square by 4 x square cancel, it means x is equal to x plus 1 is equal to 4, it means x will be equal to 3 meters. So that distance should be 3 meter in order to reach maxima at that point. Alright, ahead to another question. In this question they are asking the distance between these two sources. These two sources are given, distance between these two, it's a given 3 lambda. So this distance is 3 times of lambda, means distance between S1 to S2. And in this question they're asking how many maxima will occur. So for maxima will appear. How many maxima will appear? For maximum we know phase difference is equal to 2 and pi, but path difference, that should be equal to n into lambda. So path difference can be 0, can be lambda, can be 2 lambda, and so on, 3 lambda, 4 lambda, and 5 lambda, and so on. So if I get path difference 0 means maxima. If I get path difference lambda means also maxima. 2 lambda means also maxima. So if I check this point in this diagram, this point over here, so this distance S1P and S2P both are equal. So here path difference S1P and S2P both are equal. It means here path difference will be 0. So first maxima I will get over here. And if you check this point, here path difference will be 3 lambda. Why? Because S1k minus S2k, that will be equal to 3 lambda. It means here path difference is 3 lambda and here path difference is 0. At this point it's 0. So here also path difference will be 0 by same logic, and here path difference will be 3 lambda. It means if it is 0 path difference and if we keep on moving this one in clockwise, just you see that one line will increase and another line will decrease. So in between it has to reach from 0 to 3 lambda, means in between we will get lambda, then 2 lambda, and we got at this point 3 lambda. Then again at this point I'll get 2 lambda, then lambda, then again 0. At this point again lambda, then 2 lambda, and then 3 lambda, and then again this one will be 2 lambda, then lambda, then again 0. If I count this complete number of points, that total number of points will be 12. So at 12 places there will be the maxima in this case. We can count this point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.